Hello friends and my dear students, I hope you are all well and your studies are also going on well. In this video, which is part 4 on the chapter Congruence, I will solve problems from the textbook of author RS Aggarwal. From the exercise 16, I will solve the problems 1, part 4, problem number 2, 3 and problem number 4. If you have not watched the previous 3 videos where I discussed about all the theoretical concepts of congruence of triangles and also congruence of plane figures, then I highly suggest that you please watch the previous 3 videos, part 1, part 2 and part 3 videos, which will give you a good understanding about the correspondence of two triangles between triangles and the congruence of two triangles and all the concepts regarding matching parts, pairs of matching parts, and the 4 conditions of congruence, that is SSS, SAS, ASA and RHS. I have thoroughly covered all these concepts in the previous 3 videos. So this video is part of the playlist CBSE Mathematics for class 7 following the textbook of author RS Aggarwal. And if you are new to my channel or not yet subscribed, and if you are watching my videos regularly and if my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So in this part 4 video, I will solve the problem 1, 2, 3 and 4 from exercise 16, and the rest of the problems I will solve them in another 2 videos. So in 3 videos, I will solve all the problems of exercise 16. So let's get started with this video. Okay, so I do not have notes. I just have copied all the problems that I will solve in the canvas. I hope you can read the questions. Even though I do not have a good handwriting, I hope it is readable. You can figure it out what the question is saying and the writings and the figures. So I will solve question number 1, part 1 and part 2. Question number 2, all the 4 parts and all the 5 parts, and question number 3 and question number 4. Okay, so let's start. Question number 1 says, state the correspondence between the vertices, sides and angles between given pairs of congruent triangles. Okay, so congruence of two triangles is given, that is in the first first part. It is given that triangle ABC is congruent to triangle EFD, and the letters, ordering of the letters, as you know, the ordering of the letters in expressing the congruence of two triangles matters. Now we know that if this is given, this will imply it has asked the correspondence between the vertices, sides and angles. So this will imply, of course, if we consider the vertices, the first letter of the first triangle is A, it will correspond to the first letter in the second triangle, that is E. Similarly, we have B will correspond to F and C will correspond to D. Now once you have the correspondence of the vertices between two triangles, the correspondence of the 3 sides of the 2 triangles automatically follows. Now this will imply that AB, the side AB corresponds to the side EF, the sides BC corresponds to the side FD. Now how I am saying this, that side AB, because for sides, if the congruence, if the congruency of the congruence of two triangles is given, then you take 2 letters at a time. So in triangle ABC, if I take 2 letters at a time, I get the sides. The first 2 letters is AB, A and B, so I get the side AB. The second 2 letters are the B and C, so I get the side BC, and the third pair of pair of vertices is C and A, so I get the side CA. So correspondingly, you take the corresponding, you know the correspondence of the vertices. So definitely you will know what is the corresponding side of a side in triangle ABC in the triangle EFD. So AB will correspond to EF. So BC is will correspond to FD, and similarly CA, the side CA will correspond to the side DE. So we have the correspondence of the vertices, correspondence of the sides, and of course the angles is automatically implied from the correspondence of the letters, the vertices. As you know that the angles in a triangle are named after the vertices. So definitely angle A will correspond to angle E. So this question has asked about the correspondence between the vertices, sides and angles, and not the equality. So angle B will correspond to angle F, and similarly angle C will correspond to angle D. Okay, let's see the part 2. We have triangle MPN is congruent to triangle SQR. So first let's write down the correspondence of the vertices. So definitely, as I explained for part 1, M will correspond to S, P will correspond to Q, and N will correspond to R. About the sides, if you take two letters at a time from both the triangles, you will get MP corresponds to the side SQ, PN corresponds to the side QR, and finally NM side NM corresponds to the side RS. And about the angles, the correspondence of the angles will follow from the correspondence of the vertices. So we will have angle M corresponds to angle S, angle P will correspond to angle Q, and angle N will correspond to angle R. I hope this is clear. This is not really that difficult. Writing the correspondence of the vertices, sides and angles from the given congruency of two triangles. Okay. Question number 2 says that some pairs of congruent triangles are given. So we have 1, 2, 3, 4 and 5 parts. A pair of two congruent triangles are given, and it is indicated. Indication is given in the figure, which regarding the equality of sides or angles. Now it is asking the property of congruence. So all these triangles are congruent triangles, so definitely they will be congruent. We have to say, based on whatever information, that is equality of the sides or angles is given, what property of congruence, that is we have 4 conditions of congruence or 4 criteria of congruence in two triangles. We have to mention which one of them has been applied or is applicable to prove the congruency of these two of the given pair of congruent triangles. Okay. So part 1, we are given angle triangle ABC and DEF, and we can clearly see as it is visually marked in the figures that we have AC is equal to DE. Now please note that it is from this figure an indication of the equality of the sides. I can say that AC is equal to DE. It doesn't matter. I could have also said that CA is equal to DE, or I could have also said CA is equal to ED. It doesn't really matter, since ACDE, these are lengths. Okay, we have this. what else we have? We can see that two sides are given to be equal. So we have also, let's say, BC is equal to EF. Now I can also say this BC is equal to EF or BC is equal to FE. These are this will not really matter, or CB equals to FE. This will not matter. Okay. What else we have? We have the angles. We can see that two sides, equality of two sides is given, and also the angle is given. It is given that angle C is equal to angle B. So we can see in the three matching parts, one is angle and two are sides. So definitely we can see that we have two sides and one angle. Now two sides and one angle can be either two sides and one angle has to be SAS. We have no other choice. As per the four conditions of congruence, or four criteria of congruence, we know it is SSS, that is three sides, or SAS, which is two sides one angle, or it is ASA, which is two angles one side, and we have RHS. Now since in this figure given congruent triangles, we can see that we are having two sides are equal to the corresponding sides. The two corresponding sides are equal, and one angle is corresponding angle is equal. And also we can see that in the triangle ABC, AC and the two sides, the two equal sides which are given. I mean, in the so you know that in congruence, in establishing congruence of two triangles, we need three pairs of matching parts. So in the three pairs of matching parts, we can see two pairs are two sides and one angle. And in the triangle ABC, the sides are AC and BC, and and we can also see their included angle. These are the three matching parts involved in the in establishing the congruency of these two triangles, and this is the C. So AC, the side AC and BC, the common letter is C. Obviously, the angle included between AC and BC is angle C. Also, in this triangle DEF, we can see that DE, we have DE and EF and their included angle, which is of course angle E. So clearly these are the matching parts. We can say three matching parts. These are the three matching parts, and these are the three matching parts of triangles DEF. DE, the side DE, EF and their included angle are the matching parts of triangle DEF, or three matching parts, since we know that we are this is about the triangle DEF. So the side AC, BC and their included angle triangle C are the three matching parts which is involved in this congruency, and the corresponding sides and their included angles in the triangle DEF are DEEF and the included angle E. So clearly this is a which condition is satisfied. This is two sides and the included angle, that is S, that is SAS. This condition is this property or this condition or this criteria of congruence is being applied, or based on this criteria these two triangles are congruent, we can say. And it has also asked the name of name the congruent triangles, that is it is asking about the congruence name, that is congruence name, that is the how the triangle ABC is what is the correspondence basically between the triangle ABC and DEF under which these two triangles are congruent. So we can see that since angle C is equal to angle E, definitely vertex C will correspond to vertex E. So now angle C equals angle E implies that C will correspond to vertex C will correspond to vertex E. Okay. How do we get the corresponding of the other two vertices, that is A and B in triangle ABC? Now we also know that AC is equal to DE. Now AC equals to DE, and the fact that C has a correspondence with E will imply AC is equals to DE, will imply that we know that AC is equal to DE, and we also know that the vertex C has a correspondence with vertex E. Now in AC equals to DE, C has a correspondence with E, we know. So this will automatically imply that A will have a correspondence with D. So we have, so this will imply these two, that AC equals to DE and that there is a mapping correspondence between the vertex C and E, will imply that A will have a correspondence with D. And once we know the correspondence of two vertices A and C in triangle ABC, this will automatically imply that B will have a correspondence with F. So this implies that triangle, the congruence name or the congruence name will be, we can say, triangle ABC is congruent to triangle DFE. So this is the congruence relation or congruence name, whatever you call it. Okay, let's do part 2. Part 2, we can see that, so this is about two right angle triangles. So definitely since triangles are right angled, and also it is given, since triangles are right angled and also it is given that these two triangles are congruent, this will imply RHS congruence property is being applied to verify the congruence of these two triangles. Congruence property, or also it is named RHS congruence property, or RHS congruence you can say criteria or condition. This RHS congruence criteria or property is being applied. Now we have to find the congruence name. How do we do that? Now from the figure we can clearly see that angle P is equal to angle N is equal to 90 degree. So this will imply P has a correspondence, vertex P has a correspondence with vertex N. Okay. Now we can also see that the sides, regarding the two arms being equal, we have PQ equals to Mn. PQ equals to Mn. Now we also know that P has a correspondence with N. So now from PQ equals to Mn, we know that P has a correspondence with N. So definitely, since PQ equals to Mn, so definitely Q should have a correspondence with M. So this implies, that is, PQ equals to Mn, and the fact that P has a correspondence with N will imply that Q has a correspondence with M. So we automatically get that P has a correspondence with N, Q has a correspondence with M. So definitely R should have correspondence with L. So therefore, the congruence relation or the congruence name is triangle. We can say, let's say RPQ. Let's say RPQ. Now, it doesn't matter in the congruence relation how you name a triangle. You can name a triangle in any way you like, but to name accordingly, you have to name the other triangle. That is, the correspondence, it should maintain the correct correspondence. So if I say, for example, if I want to write the congruence relation, the one way I can do is RPQ is congruent to, I have to see R is having correspondence with L, so this will be L. P is having correspondence with N, so it's N, and this will be M. Or I can also write that, let's say if I do PQR, obviously PQR, this will be P has correspondence with N, Q has correspondence with M, and R has correspondence with L. So any of these two you can use as the congruence relation or congruence name. Okay. Let's do part 3. Okay. So what do we have? So we can see that in the triangle we have two triangles, ZX, XYZ and RST, and the three sides are equal. I mean, in the three pairs of matching parts we can see they are all sides. So this is a case of clearly this is a case of S congruence property, since we can see that in the three matching pairs, in all the pairs the matching parts are sides. So what do we have? So we have ZY equal to ST, we have ZX equal to RS, and we have XY equal to RT. Now how do we obtain the congruence relation, the congruence name? Clearly the congruence property is SSS because all the three sides are involved. We are having the equality of three sides with the corresponding sides. Now from this we know this. How do we know? How can we name the congruence? Now I already explained this in the previous video. If you have watched it, you will know how to name the congruence relation. How do we do it? So you take two at a time. This equality of the sides, you take two at a time. Let's say I take ZY equals to ST, and I take ZX equals to RS. you see which is the common letter in the two sides of the triangle XYZ. We have the sides ZY and ZX. So the common letter is Z. Z. For the triangle RST, the sides are ST and RS. The common letter is S. So the correspondence will be, there will be a correspondence between the vertex Z and vertex S. Now you take another two matching pairs. Let's say ZX equals RS and XY equals RT. So let's say this will imply that, not imply actually, we are using some strategy or technique to find a correspondence between two vertices. Now in the sides of the triangle XYZ are ZX and XY, so the common letter is X. And for the triangle RST, the sides are RS and RT, the common vertex is R. So we have a correspondence between X and R. So we see that Z is having a correspondence with S, X is having a correspondence with R. These two will automatically imply that Y must have a correspondence with T. So the congruence relation can be, if I take X, Y, Z, I can name it any way. I can name the first triangle in any way I like, in any order. I can use any ordering of the letters X, Y, Z. But when I write the congruency, when I will write the name of the other triangle, I have to mention the corresponding vertices. So X, its correspondence vertex is R. For Y, its corresponding vertex is T, and this will be S. This could be one way of, this could be a possible congruence name, a congruence relation. Another way, let's say if I use the naming of the first triangle ZYX, then I will have, I can write it this way: Z is mapped to S and Y is mapped to T, and this is R. Okay. Part 4. Okay, so we have the triangle DEF and triangle MNP, and we can see two angles are equal and one side is equal. So we can see what information we can see from the figure, that angle E is equal to angle N, angle F is equal to angle M, and we see EF. I can also say EF. I can also say FE. It doesn't matter. It's basically the side of the length of the side. So EF is equal to MN. So two angles and one side, and also we can see that the side is basically the included side between the two angles. Now, so things to observe is that in triangle DEF or DFE or EDF, you name it in whatever way, it doesn't matter. In triangle DEF, I can see that I can see EF, the side EF is included between the angles E and F. Also, in triangle MNP, I can see that the side MN, not side, the side MN, since it is given that the length of the side EF is equal to the length of the side MN. I know in triangle MNP, the side MN is included between angle M and N. So we see that these two triangles are congruent, and we also see that angle E is equal to angle N, angle F is equal to angle M, and also the side included between the angles E and F is equal to the side included between the angle M and N in triangle MNP, and hence this is the congruence property being applied is angle side angle, because we have angle ASA means the side included between two angles. This is the property being used. Now, how do we find the correspondence of these two triangles? Now, angle E in given two congruent triangles, if angle E in these two triangles are congruent, and if we know that angle E is equal to angle N, this will imply that E has a correspondence with N. Similarly, we will have this angle, angle F. We can see that angle F is equal to angle M, and the two triangles are congruent. So I can say F has a correspondence. The vertex F has a correspondence with the vertex M. So we know the correspondence of two vertices. So the third correspondence of the third vertices will automatically imply that is D will have a correspondence with P. So these three will automatically imply the congruence relation, that is, I can say EFD is congruent to triangle NMP, or I can say triangle DEF is congruent to triangle PNM. Okay, let's do the last part 5. Okay, so we can see now the triangles are ABC and ACD. So we can clearly see there is a common side AC. So the triangles involved are in triangle. We can see, let's say we name it the triangle ABC and triangle ACD. These are the two triangles which are given to be congruent. So we have the common side. We can clearly see, even though it is not indicated, it is obvious that AC is equal to AC. Even though this looks a little weird, but it is. Instead of writing this way, let's say it is better if we say write AC is a common side. AC is a common side. Now, if in a two triangles we have a common side, and we have a common side, then obviously you can see that the vertex A is a vertex of the triangle ABC, and it is also a vertex of the triangle ACD. So obviously the vertex A in triangle ABC will be mapped to the vertex A of the triangle ADC, and also the vertex C will be mapped vertex C of triangle ABC has to map with the vertex C of triangle ACD. Now that this is obvious. Now some angles are given. We can also see that angle B is equal to angle D, and angle B is equals to angle D. And also it is given that angle BAC is equal to angle CAD. Now, okay, so we have this BAC equals to CAD, and also we can see it is given that angle BCA is equal to angle ACD, which is given to be 60 degree, and this was equal to 50 degree. 50 degree. Now, so we can see that the three angles of the triangle ABC is equal to, because we have a corresponding equal angles in triangle ACD, but that is not causing the congruency of, that is not establishing the fact that triangle ABC and ACD are congruent. So we can now in triangle the triangles are obviously ABC and ACD, and it is given that triangle they are congruent, but we do not know yet the congruence name or the relation. We do not know the mapping. Now, what will be the what is the condition of congruency that is being applied in establishing, if we want to verify what is the congruence criteria or condition which is applicable for the congruence of these two triangles, that is triangle ABC and ACD. Is it angle cannot be angle, three angles is not a congruence condition or criteria. It can be, we know that AC is equal, this is we have a common side, that is AC is a common side to both triangle ABC and triangle ACD, and we also see the angles, we also see, okay, let's say, so we can see that the fact that, so angle BCA, that is 50 degree, is equal to angle ACD. Angle BCA is equal to angle ACD, which is 60 degree, and we also know that angle BAC, let me we know that angle BCA of triangle ABC is equal to an angle ACD of triangle ACB, which is, they are all equal to 60 degree, and also we know that the angle BAC in triangle ABC is equal to angle CAD in triangle ACD, which is equal to 50 degree, and we know that AC, even though it is looking weird, we know that AC is, let's say AC is a common side. AC is a common side. These three false. These three false. If you observe these three, if you consider these three matching pairs, that is two angles, and the side included between those two angles are same, we have the angle side angle congruence condition. The fact that angle BCA is equal to angle ACD and angle BAC is equal to angle CAD, now and AC is a common side, and we know that in triangle ABC, angle the side included between the angle BCA and BAC is AC, and also in triangle ACD, the side included between the angle ACD and CAD is also AC. So we are having we can apply the condition ASA condition criteria, that is the side between two angles. Okay. Now, what about the correspondence? Now, So the triangles are, so let's say the triangles are, so the first triangle is ABC. If I want to name the congruence relation, how do I do it? So in the triangle ABC, vertex A obviously will be have a correspondence to the same vertex in triangle ACD. So A will obviously be correspond to A. What about B? Now we can also see that C in triangle, vertex C in triangle ABC has to correspond to the vertex C of triangle ACD. So this will also be C. So obviously B has to correspond with D. So, this is considering the fact that AC is a common side and for the two triangles, and the third vertex in triangle ABC is B and the third vertex in triangle ACD is D, we can have this congruence relation, this one. But if you think in terms of that it is the congruence property or condition being applied is ASA, that is angle side angle, then angle side angle. So we know that if we consider the angle side angle, we know that angle BCA is equal to angle ACD. Now, what exactly is angle BCA in triangle ABC? It is angle C. This now this this can be rewritten as what is angle BCA in triangle ABC? It is angle C. What is angle ACD in triangle ACD? It is angle C. Okay. Now, what is angle BAC in triangle ABC? It is angle A. What is angle CAD in triangle ACD? It is angle A. Now, okay. Now, this left hand angle C is basically the angle from the triangle ABC, and the right hand side angle C is basically the angle from the triangle ACD. Similarly, this left hand angle, the angle A to the left hand side is from the triangle ABC, and the angle A to the right hand side is from the triangle ACD. Even though it is looking very weird, but it's this is how it is. Now we can say this. Now this we know will imply that C will have a correspondence with C. Now even though it's looking very weird, the same vertices, but we know that vertex A is common to both the triangles and also vertex C is common to both the triangles. We have this. If we have this, then definitely these two, that C is mapped to C and A is mapped to C, will definitely imply that B has to map with or has to have a correspondence with the vertex D of triangle ACD. Okay, let's do problem number 3. So we are given a figure. We can see that there is a ray OA and the ray OB. They have a common point O. There is another ray OC. So the ray OA, OC and OB have a common point O. Okay. And we see that PL is perpendicular to OA. So PL is perpendicular to OA. Okay. So this is definitely 90 degree, and it is also said that PM is perpendicular to OB. So this is also 90 degree, such that PL is equal to PM. So PM is equal to PL. This information we have, and it is asking, is triangle PLO congruent to triangle PMO? Now let's see if what information we can derive. Now, so consider for the two triangles for the two, we are considering the triangles POL and POM. POL and triangle POM. For the two triangles, what do we have? We have angle L is equal to angle M equal to 90 degrees. Since PL is perpendicular to OA, we will have angle PLO, which is equal to angle L 90 degree, and also angle PMO will be equal to the angle M. These angles are equal to 90 degree. Okay. What else do we have? We also have PL equals to PM. It is given, and we have OP as common side. Common side, in the previous problem I should have said AC. The AC is the length of the side. The side should be AC bar. AC bar. Okay. So we have OP as a common side. Okay. So what are the matching parts? What are the three pairs of matching parts? This is one pair of matching parts, which is angle. This is the second pair of matching parts, which is a side. So this is an angle, this is a side, and this is a side. So we have two sides and one angle, and the only option, two sides and one angle, the only possible option we can think of congruence property is SAS, two sides and one angle, which is angle between two sides. Angle between two sides. Okay. Now, angle between two OP is a common side. Okay. Okay. Before that, I think since the two triangles are right angle, it is better we consider the RHS. We try to see if we can apply the RHS congruence condition. I forgot, whenever you have in two triangles related to congruence problem, two triangles, if you see that the two triangles are right angle, always first see if you can apply the RHS rule. I just forgot that. So this we are having, so this is actually should not be discussed. Okay. Now, for the two, actually this whole thing is actually not the correct way of solving. We have triangle POL and triangle POM are, it is asking this. So we should, it's better we use the same naming of the triangle. So triangle PLO and triangle PMO are right angled at angle L and angle M respectively. We know this. So this is a fact. These two triangles are right angled, and the triangle PLO is right angled at angle L, and triangle PMO is right angled at angle M. Okay. That is angle M is equal to angle L is equal to 90 degree. This implies that OP is hypotenuse, is common hypotenuse of triangle PLO and triangle PMO. So we can see that the hypotenuse of triangle PLO, which is OP, is equal to the hypotenuse of triangle PMO, which is also OP. Rather, I should say OP this. So to apply RHS congruence condition, I need one arm, and also it is given arm also we can see that also PL is equal to PM, and PL is an arm of triangle PLO, and PM is an arm of triangle PMO. So we can see that we are having two triangles. The triangles PLO and PMO, they are both right angle triangles. They have a common hypotenuse, that is their hypotenuse are same, and and also one arm, that is the arm PL of triangle PLO, is equal to the arm PM of triangle PMO. So clearly this is the condition, congruence condition being applied or applicable is RHS. Now, and hence these triangles are congruent. We can say that using the RHS congruence condition, we can say that triangle PLO is congruent to triangle PMO. Now, let me check if the naming of the triangles is correct, is given correctly in the congruence relation. So we have P goes P, okay, fine, and the angle L and M must go, they must must have a correspondence, because both the angle L in triangle PLO is right angle, and also an angle M in triangle PMO is right angle. So they must correspond to each other. So L must have a correspondence to M, and definitely the remaining vertex O is also common. Vertex O and P are common, and so definitely, so this naming convention is correct. So we have triangle PLO is congruent to triangle PMO. So the idea was that the two triangles are first of all congruent, as PL was perpendicular to OA. So we have angle PLO or angle L in triangle PLO is right angle. Again, PM was said to be perpendicular to OB, which makes angle PMO, that is angle M in triangle PMO, right angle. So these two triangles are right angled, and they have a common hypotenuse, and also one arm. The two arms, we have two equal corresponding arms. That is, it was said PL is equal to PM, and PL is an arm of the triangle PLO, and PM is an arm of the triangle PMO, and they are equal, and hence the RHS congruence condition or criteria is applied, and we have the triangle PLO congruent to triangle PMO. Okay, we have another problem. This is problem 4. It says that in this figure, AD is equal to BC. AD is equal to, so this is AD, it is looking like P. This is AD. So AD is equal to P, that is the length of side AD is equal to the length of the side BC, and also given that AD is parallel to BC. AD is parallel to BC. Now, if AD is parallel to, it is given that AD is parallel to BC. From the fact that AD is parallel to BC and AC is a transversal. So for this, you must have completed the chapter properties of parallel lines. I have already covered that chapter. If you wish, you can from the same playlist, that is CBSE Maths 7 RS Aggarwal, you can find all my videos on the chapter properties of parallel lines. So we have AD is parallel to BC, and AC is a transversal. This will imply the alternating interior angles will be equal. So I will have this angle equal to this angle. So okay, so I will have angle DAC equal to angle ACB. It is asking whether AB is equal to DC or not. AB is equal to DC or not. So we will try to see if the two triangles formed are angle ADC and angle ABC. So from the AD is parallel to BC and AC is a transversal, we got that angle DAC is equal to angle ACB. Now consider triangles ADC and triangle ABC. Let's consider these two triangles and see if we can prove them to be congruent, and then we can, if I can prove if these two triangles are proved to be congruent, then I can obviously say that AB will be equal to DC if at all from the congruence of the two triangles, if AB is the corresponding side to the side DC. Now consider triangles ADC and ABC. So what do we have? We have triangle angle DAC equal to angle ACB, or in terms of the angles of the two triangles, I can say angle DAC, angle A is equal to angle C. That is, angle A of the triangle ADC is equal to angle C of the triangle ABC. ABC. Actually, we should not write this. No, this will not be really correct. Let it be like this. We have angle DAC is equal to angle ACB. Okay. Now, also we have AC is a common side. They have AC is a common side. So we have an equal side. Since one side is common to both the triangles, AC is a common side. Now, what else do we have? Also, you can see the fact that AD is parallel to BC and AC is a transversal. We can also see that it is given. It is given that AD is equal to BC. So AC is a common side, and also given AD is equal to BC. Now, so we got three pairs of matching parts. This is one pair of matching parts, this is second pair of matching parts, and this is third pair of matching parts. Now this pair of matching parts are the angle DAC and is equal to angle ACB. Okay. We have AC is the common side. AC is the common side. So I can like this. AC is the common side. And also we have AD equals to BC. Now, in triangle ADC, we observe that in triangle ADC, angle DAC is included between the sides, I can say AC and AD. For the triangle ADC, I can say that it is clear that angle DAC is an angle included between the sides AC and AD. Also, in triangle ABC, angle ACB is included or is an including angle, whatever way you understand it. I mean, this is angle ACB is included between the sides. ACB is included between the sides AC and BC and BC. So you can clearly see that angle DAC is equal to angle ACB. AC is a common side, that AC of triangle ADC is equal to AC of triangle ABC, and so this is a kind of angle. This is angle matching. This is a kind of a side matching, and this is also side matching. Now, since so the only, and we see that also that the angle DAC for the triangle ADC, the angle DAC is the included angle between AC and DC, AC and AD. And in triangle ABC, we see that angle ACB is the included angle between AC and BC. So definitely, we see that the congruence property or criteria that can be applied for the congruence of these two triangles, ABC, ADC and ABC, is angle side, not angle side angle, but side angle side. Two sides, one angle, that is two sides and the included angle. Now, this implies since we can apply the SAS condition criteria is satisfied, we can say triangle ADC is congruent to triangle. What will be the congruence relation? What are the mappings between the triangles ADC and ABC? Obviously, we can see two common vertex A and C. Obviously, A will be mapped to vertex A of triangle ADC, will obviously map to vertex A of triangle ABC. Also, vertex C of triangle ADC will obviously map with vertex C of triangle ABC. So the vertex D of triangle ADC has to map with the vertex B of triangle ABC, and we get it. Triangle ADC is congruent to triangle ABC. Now, since we have established this congruence between the triangles ADC and ABC, we can say that its corresponding sides are equal, and hence we say that AB that is from this AB is equal to DC, that is from the side AB is the side of triangle ABC, and the corresponding sides in triangle ADC will be AD. So this is proved. Okay, that is all for solving the selected problems from exercise 16. I will, in the next video, that is part 5, I will solve the next couple of questions, and the final remaining questions I will solve in another video. So there will be 2 more videos, and I will complete solving all the questions of exercise 16. So if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. And please stay tuned for the next 2 videos where I will be solving the remaining problems of exercise 16. So this is chapter Congruence. Thanks for watching, and until the next video, take care and bye.